Okay, last chapter 8 video, we're going to be focusing on rational inequalities this time rather than rational equations. So the setup is a little bit different than the way that we solve rational equations. Seems like it would be pretty similar, but it's actually quite a bit different. One of the reasons is because of the domain restrictions, things that you're not allowed to plug into the denominator. So I'm going to give you guys step by step. We've got 4 steps that we're going to follow here, and then just 2 examples should give us a pretty good idea of what we're going to be doing. So it should be a relatively quick set of notes. So step 1. Step 1 is to state the excluded values. So this is the same thing as your domain restrictions. All right, so the excluded values are the ones that don't work, the ones that you're not allowed to plug in, whatever the domain restrictions are. So what you do for that is you set the denominator equal to 0. Okay, so as we're writing down these steps, I'm going to follow through and do each step with example 6 part A. Okay, so starting with the excluded values, if you take a look at the denominator, here I'm not allowed to plug in 0, because if x were 0, then that denominator would be 0. So x can't equal, I'm not allowed to plug in 0. If we check this denominator right here, I also cannot plug in 0 there. If I set 5x equal to 0, I'd also get 0. And then here it's a 3. There isn't even a variable there, so that's weird. So that's our excluded value. We need to write that down first, and that'll come up in later steps. Second step is to solve the related equation. So basically we write it as an equation and solve that. Okay, so we're going to do that next step. So write it down as an equation. So 5 over x and then plus 6 over 5x. We're going to write it as an equation and then solve that. So same steps that we were doing yesterday. Same process for solving equations. And so the first thing we need to do for this is come up with our LCD. Okay, so our LCD, I'm basically just going to take all the pieces that we need here. So both of these have an x, so our LCD is definitely going to have an x, but I need a number too. And then we're looking between 5 and 3. So what's the least common denominator between 5 and 3? What's a multiple of both of them, but the smallest possible multiple, and that would be a 15. So this process is the exact same as it was yesterday. We are going to multiply both sides of the equation by a 15x, which means we distribute. We multiply here, here, and here, all by a 15x. So I'm going to color coordinate again so we can see all of this. So we've got 5x and then plus, leave a space for the LCD, equals, leave a space for the LCD. Okay, so I'm going to multiply both sides by a 15x. So multiply here, and multiply here. And then the next step is to reduce down our common factors. All right, so here, for instance, I've got an x that cancels. Here, the 15 over 5 reduces down to 3. And then here, the 15 over 3 reduces down to 5. All right, so let's multiply everything out. So here I have a 15 times 5 left, and that's a 75. Plus, and then I have a 3 times x times 6. So, oops, I forgot to cancel my x's here. Sorry, cancel these x's. Okay, so no x. Sorry. I just have a 3 and a 6. So 3 times 6 is 18. Equals, and then here I have 5 times x times 2. So on that right-hand side, I have a 10x. Okay, so on my left-hand side, I'm going to add 75 plus 18, and I get 93 equals 10x. And then to get the x by itself, I divide both sides by 10. Okay, so remember when you divide things by 10, it's like moving the decimal place over? So I get 9.3. All right, but that's not my answer. That's just step 2, because really I have an inequality here, so all I did was I solved the related equation. Third step, this is the part that's a little weird, so I'll walk through it nice and slowly. You divide a number line into intervals. Divide a number line into intervals using the numbers from steps 1 and 2. Okay, so I'll show you what we mean here. So you're going to draw a number line, and then you're going to mark on the values that you came up with. So we came up with values of 0 and 9.3. So you're going to use those to divide up a number line. Make sure they're in numerical order. So we'll put a 0 here and a 9.3 right here. Again, please be sure they're in numerical order. So that's the next step. For step 3, we haven't really done anything with that number line yet. We just set it up in step 3. And then for step 4, we are going to test some sample values. Okay, and again, those words don't necessarily make a lot of sense without looking at an example. What we do is, so now we've got 3 separate intervals. We divided all of the numbers in the whole wide world into 3 different categories. We've got the numbers over here that are smaller than 0, the numbers in here that are between 0 and 9.3, and then the numbers that are bigger than 9.3. Okay, so this is the part where we come up with our answer. So we are going to test 3 different values, 1 in every interval. So we're going to test, let's see, pick something over here. So any negative number that you want, really. So I mean, -1 is nice and easy. So first we'll test -1, then something in between. So pick whatever your favorite number is between 0 and 9.3. Maybe it's 4. Anything you want, as long as it's in this category. Then something bigger than 9.3, like maybe 10. But maybe it's 700. I don't know what your favorite number is bigger than 9.3. Point is, it doesn't matter. I want to pick 10. Okay, so here's what I mean by test. When I say test, I am going to plug this value into this expression right here. Okay? So this part is very important to pay attention because we're going to do it all on the calculator. Okay? This work I'll need to see. I need to see that work for sure. So here's what I'm going to do. Very, very important that we pay attention during this part because this is how we come up with our answer. So I'm going to test -1. So I'm going to take -1. I'm going to store it in as x. Okay, that's the first step. Whoops, glare. There we go. Okay, now I'm going to type in this inequality exactly the way it's written. Okay, so be very careful with the fractions and stuff. So at control divide, get a fraction for 5 over x, and then plus, do another fraction for 6 over 5x, and then greater than, pay attention here. See where the equal sign is, and then hopefully you can see in blue, I've got a bunch of symbols there. So if I hit control first and then hit that equal sign, it gives me all of my inequalities. So the first one is the greater than, so select that. And then one last fraction for 2 over 3. Okay, so what I'm basically doing is I'm going to do a true-false check to see if the -1 makes my inequality that I started with either true or false. So hit enter, and it makes it false. Doesn't mean I did anything wrong, it just means that nothing in here will work. Okay, so that gives me a false statement. And you could test anything else, anything in here, anything less than 0. So say I tested like -358. 0.2. Why not? Store that in as x. If I go and copy paste here, that's also false. So no matter what test value I had picked, if it's in this region of the number line, it's going to make it false. Let me color code here. Oops, ignore that. Go away, scratch pad. There we go. Okay, so anything in this region is false. That's the first thing that I just proved. Then I'm going to test 4, or really anything I want in there. Okay, so I'm going to test 4, store that in as x. And then rather than retyping this inequality, I'm just going to arrow up a couple times till it's blue, and then hit enter, and then check it, and I get a true. Okay, so that one actually worked. So this came out to be true. You can test anything you want in this interval. Maybe you want to check like 0.01, something that's just barely in that interval. If we store that in as x and test it out, that works too. So anything in between 0 and 9.3 would work. So this region turned out to be true. And then my final region, I'm going to test something over here. So I chose 10, but I can choose anything I wanted. I'm going to store 10 in as x this time. So I'm basically plugging it into this inequality and seeing if it comes out to be true or false. So arrow up a couple more times, enter once to paste it, enter again to test it, and I get a false. So this region right here turns out to be false. Okay, so that's false. Here's the region that I care about. I want this inequality to be true. Why would I want it to be false? I want it to be true. So I pick this region right here. That's where it came out to be true. Okay, so write that in inequality form. Inequality form means anything in between 0 and 9.3. So I write it like this. Anything in between 0 and 9.3. Now, we also need to figure out whether there would be an or equal to here. There will not be an or equal to here because x can't equal 0. And then to figure out this one, I look at my original. Since this does not have an or equal to, this does not have an or equal to. So that would be your final answer. Anything that you plug in this range will make the inequality true. Anything that you plug in outside of that range will make the inequality false. That's why we did this true-false check here. All right, let's do this second and final example for Chapter 8. So start with step number 1. State the excluded values. Basically, you're setting the denominators equal to 0. So my excluded values, if I set 3x equal to 0, I get 0. If I set x equal to 0, I obviously get 0. And then 9 doesn't have any variables, so it's just this one. So that's going to be part of our number line. But we'll solve the equation first and figure out what the other one's going to be. So step 2. Solve the related equation. That basically just means turn the inequality into an equation and solve it. So equals 5 over 9. Okay, so in order to solve, I use the same steps that I used the other day and the same steps that I just used up here. I first find the LCD. So let's look at numbers first. My numbers are 3 and 9. We want to know what's the lowest thing that's a multiple of 3 and also a multiple of 9. Well, 9 is a multiple of 3, and it's obviously a multiple of itself, so that works. These both have x's, so my LCD needs to have an x. Remember, the whole point of multiplying by an LCD is to get the denominators to cancel. So really, in this section, what you should be asking yourself is, will this LCD make all of my denominators cancel? It'll make this cancel, it'll make this cancel, and it'll make this cancel. So you picked the right one. All right, next step is we are going to multiply everything, all 3 of those terms, by the LCD. Okay, so I'm going to rewrite it right here. So 4 over 3x plus, leave a space for the LCD, equals, leave a space for the LCD. Okay, so multiply both sides, and on the left I distribute the 9x. Really remember, you're technically multiplying by the numerator only. Next, reduce down your common factors. So 9x over 3x. The 9 over 3 reduces down to 3, and the x's cancel. Here the x's cancel, and here the 9's cancel. Okay, so like I said before, we did a good job of picking the LCD because all the denominators canceled. So now let's rewrite what we have. 3 times 4 is 12, plus 9 times 7, 63, equals x times 5, which is 5x. So really similar equation to the one we have up above. So combine these two, we get 75, 12 plus 63, equals 5x, and then to get the x by itself, we divide both sides by 5. So the 5's will cancel over here, and I end up with x equals 15. Okay, so this is not my answer. Remember, this is just part of step 2. Next step, step 3, set up a number line using the 2 numbers that we just came up with. So set up a number line. I use 0 and 15 to divide up my number line. 0 and 15. Okay, that's step 3. Step 3 is a very, very quick step. Step 4 is to test sample values. So you can pick any sample values you want. All right, so test anything you want. And I'm just going to pick stupid values just to show you that you can test anything you want in that interval. So this interval right here, I'm going to choose a negative 12.7 just because I can. It is in that interval, and that's what I'm going to test. And then in this interval, you know what, I'm gonna test pi in that interval. All right, 3.14 approximately, it's somewhere in that interval. And in this interval up here, let's see, I'm going to test 1,000. Anything you want. I am trying to emphasize that right now. You can test anything you want as long as it falls in these intervals. So numbers smaller than 0, numbers between 0 and 15, and numbers that are bigger than 15. Anything you want. Get creative, I don't care. Or don't. Be uncreative. Okay, so don't mind all this here. I'm just going to clear this off. Start with a clean slate. All right, so let's start with this first value, negative 12.7, or whatever other wonderfully creative value you've chosen for yourself for this first one. Store it in as x. Okay, now type in this inequality. So first fraction is 4 over 3x plus my next fraction is 7 over x. And then back into the equal sign, hit control first, control equal. Make sure you take the less than or equal to. You've got the right symbol there. Last fraction is a 5/9. Double check that it's all typed in correctly, matches perfectly, hit enter, and we get true. Okay, so I got a true for this one right here. This turned out to be true, so I'm going to label it on my number line. So anything smaller than 0 will make my inequality true. Let's check something in here. So I'm going to check pi. So my pi button, just for fun, right here next to the h. So hit that button and then select the pi. Store that in as x. And then I'm going to copy paste, so arrow up a handful of times, hit enter, and that's false. Okay, or anything else that you checked, whatever you chose to use between 0 and 15. Okay, and then my final region, I chose 1,000. Falls into the category of numbers bigger than 15. Okay, so for my last test value, plug that in for x, arrow up, I believe it's 4 times, select my inequality, hit enter, and that is true. All right, so numbers bigger than 15 are true. Okay, so those are my 2 different regions. I have 2 different things that I'm going to plug in here. So this region right here, this is described as numbers that are less than 0, and now I don't have the or equal to, and so I don't include it right here because of this right here. X can't equal 0, so I don't put it there. Or, and then you have a separate piece over here. My x values can be anything bigger than 15. So now look for this one, look back at my original. This one does have the or equal to, so I include the or equal to right here. Okay, since x can't be 0, this will never have the or equal to no matter what this one was. All right, so that is your final answer. The values that will make this true are any numbers in either of these 2 categories, but not in between. All right, that's the end of chapter 8.